Smart Buildings Academy podcast with Phil Zito, episode 353. Hey folks, Phil Zito here, and welcome to episode 353 of the Smart Buildings Academy podcast. In this episode, we are going to be talking about how to systemize your building automation career. Okay, so everything that we discussed today will be available at podcast.smartbuildingsacademy.com/353. As always, wherever you're listening, please use the chat feature, like, subscribe, and comment, and let's get on with the show. All right. Oftentimes, and this is happening with increasing frequency, it's actually pretty surprising to me how much I'm noticing this. And maybe it's because I'm looking for it. But folks are asking, how do they get into building automation? How do they get to the next level in their career? Like, what do they do? What can they do to go and ensure? And I'm just going to double check sound real quick. Just make sure. I'm always paranoid about sound nowadays. Okay, we're good. All right. So what can people do to really take their career to the next level? And oftentimes I will sit there and I will ask folks, well, what do you enjoy doing? What do you want to do? And there is definitely a discovery piece, and we'll come back to that in just a second. But what really sets the people apart from the people who go from being a technician to a programmer in a matter of months. You know, I'm thinking of Armando, who's one of our students. Shout out Armando, who, you know, went and was able to go and really take his career from being a resi electrical / HVAC guy to being a BAS designer and BAS programmer in about a year. Now, how do you do that, and how do you be effective at that? It's actually not as hard as you think. So the trick to being able to go and accelerate your career is creating a system of progression. What do I mean by a system of progression? I've got 2 water bottles this time, folks, so I'm not going to be coughing like crazy. All right, well, system of progression is 1, you identify your start point. 2, you identify your end point. And that's pretty easy. You know, if you're able to do an honest assessment of yourself and you're able to say, you know, I have no HVAC background, no electrical background, I don't know what a computer is, etc. Like, that's worst case scenario. And I want to be someone who's writing APIs for a major Fortune 100 company. Okay, so we've got our 1 start point and we've got our 1 end point. Now, the tricky part where everyone gets kind of held up is in the middle. That's where folks go and they really struggle to figure out what they're going to do. So that is what we're going to focus on today. So the first things first, got to figure out the end point. Where do you want to end up? What are you passionate about? Now, the reality is you may start by saying, Phil, I'm really passionate with working with my hands. You know, that's very, very interesting to me. I like to be outside doing work, et cetera, et cetera. And then, you know, you pull it back, get sciatica, and next thing you know, you're like, Phil, I'd really like to sit at a desk and write programs every day. Okay, well, those are 2 totally different things. So things will come up in life. That being said, do your best to figure out what you like to do so you can figure out your end position. How do you figure out what you like to do? Well, you look at the times when stuff just seemed to fly by. When did you go and, you know, lose track of time because you were working on something? Maybe it was when you were designing something. Maybe you're fidgeting with something, trying to troubleshoot it. Maybe you're trying to like sit and engineer out some home improvement project. Those can all be signs of maybe if you like to troubleshoot, maybe you want to move into a lead service tech role. If you like to do home projects of some sort, maybe you want to do project management or design role. If you sit there and you like to work with your hands, maybe you want to be a technician role. And if you like computers, you find yourself losing yourself on Stack Exchange and stuff like that, maybe you want to be a programmer or an integrator. Once you've got that idea, then you put that at your endpoint. Now you look at what do you need to do in order to have that role. So if I were to go here and I type in building automation programmer. I type that in and kind of see, what do we got here? I got a controls designer. I want to find a programmer job role here. Let's see if I can do that. And I know you can't see my screen right now. I'm not sharing it. But let's see. Oh, controls engineer. That usually is someone who needs to program. All right. So, okay. Now that I see this programming job description here, I'm going to start to figure out, what do I need? Okay, it's got some useless stuff in the job description, not very helpful. I need an analytical mindset or educational experience and stuff like that. But it does go into a couple things. You shall be responsible with end-to-end programming, including creating the program, testing the program, and troubleshooting the program. Okay, that's good. We have to go and test, right? We have to write a program. We have to troubleshoot a program. So we've got a couple things going on here that we can go and say, these are the things we need to do. Now, let's stick with writing a program. Okay, so writing a building automation program. What do you need to know to do that? Well, if you've been through our programming course, our approach to programming is to read the sequence of operations, break it out into segment chunks, identify the design patterns, and write the program. Now, the biggest challenge any of you listening to this are going to face, if you are not in the industry right now, is getting your hands on building automation stuff. Like, how can you go about, I'm going to take another sip of water here. How can you go about getting your hands on building automation gear so that you can test out and work on all this stuff? Easy.io, I don't know how accessible their stuff is anymore now that they've been acquired by Johnson Controls, but that used to be one of my go-tos. Contemporary Controls, they're still a good go-to for lab material. Anyone who's based on like the Sedona framework, they're pretty open. Excuse me. Everyone's got issues getting materials right now, so you just got to accept that. But getting your hands on the software, going to any Sedona platform is usually going to be one of your easiest ways. As I see someone saying it's hard because it's locked behind vendors. That's why, I point people to like Contemporary Control and their BACnet Pi. I think it's called Back Pi board. It's a Raspberry Pi board that runs the Sedona framework, and Sedona is going to give you the ability to do graphics. That Pi board is going to give you the ability to do basic I/O. It's going to give you the ability to mess with BACnet MSTP, BACnet IP, SNMP, OPC, etc. It's going to give you the ability to do some basic server stuff, I believe. So yeah, it's a good labbing product. So once you've got that out of the way, let's back into that write a program. Okay, so you're here with no experience and you want to get to here writing a program. How can you do it? Well, the first thing is we have to say, like I said, what does it take to write a program? You have to understand BAS software. You have to understand HVAC, and you have to be able to interpret HVAC documentation in order to go and turn that documentation into code. So, we wrote up our ultimate guide to building automation programming, where it goes through kind of an approach on programming. But what I would do, excuse me, I must be coming down with a cold because my throat's been so dry lately. But as I was saying, what you're going to do here, you've got your programming, okay? And you've broken out HVAC into a portion. Now, a lot of folks will tell you need to be a mechanic to properly understand HVAC, et cetera, et cetera. I have no mechanical background, yet I was programming within a year due to this approach. What I did was I went and studied ASHRAE manuals on HVAC sequencing. I went and identified, okay, what are the concepts that repeat here? And this is where the different kind of thinking comes into play, is you start to identify the patterns. So you have to understand HVAC theory, things like psychrometrics, things like heat transfer, things like systems operations, safety, etc. But you also have to go and you have to understand what that translates to in code. Now, once you've done that and you've started to build out this HVAC training portion of it, you obviously have the BAS portion of it. So now you have to take that HVAC experience and translate that to code. And you start with stuff that's super duper simple, right? An exhaust fan. How do you go and you program an exhaust fan? I think most of us would say for an exhaust fan, you take a comparative object, right? A comparative object is going to compare two numeric values. And it's going to say, when numeric value is greater than the numeric value 2, numeric value 1 is greater than numeric value 2, enables a Boolean output, which enables a fan. So you've learned a basic programming pattern. Now with that pattern, that same comparative pattern, you can enable chillers, you can enable boilers. So you have to know HVAC theory, not HVAC hands-on, but HVAC theory. And then you have to understand patterns. And for those of you who are managers who are listening to this, this is the exact way that you can develop your own team. And for those of you who are self-developing, same thing, right? You sit there and you say, okay, now I have to learn my patterns. Once you learn those patterns, you can move progressively. Once you've mastered one pattern, you can move progressively to other sequences. Now, note that all along the way here, you're doing this all alone. I realize that it's going to be very difficult. I realize that it is going to be challenging. So ideally, you would get yourself a mentor. You would get yourself a BAS mentor, maybe even get a job at a BAS company. And along the way, you are studying these things. You're doing your day-to-day installer tasks or your designer tasks, whatever role you have. And then you're doing these tasks outside of work hours. Once you have gone and you've built up your understanding of a design library, so HVAC design libraries, now you're going to go and start writing full-fledged programs. And you're going to test these out, see if they work, which will bring up our next topic in just a second. So we've got HVAC, we've got programming, design patterns, and we've got writing full-blown programs. That takes care of the programming piece, but now we still have the test and we have the support. So now we move on to testing, and now you've got to start learning your testing methodologies, where this is where you would research, how do I test programs? And you're going to get a lot of line code stuff that's not going to make sense to you. But there are going to be a couple things: variable testing, read-through testing, isolation testing. Those are the three primary testing methodologies we teach. Variable testing is where you change a variable and you see if it affects the program the way it should. Read-through testing is you read through the sequence and you try to execute the sequence. And then isolation testing is where you isolate a certain portion of the sequence and you test. So once you've learned these test methodologies and you've practiced them, right, then you can move to the final phase, which is troubleshooting. And this is where you can work, with your company, or maybe you join a community like our Smart Buildings community, which I'll link to at podcast.smartbuildingsacademy.com/353. But you can join a community and you can start asking for code. And then you can say, hey, can you send me bad code? And you can try to figure out why it's bad code. You can start troubleshooting it. And you can start figuring out, why is this code bad? Because reading bad code is going to teach you how to write good code. And so through all of this, right, you've got a system now, a systemized approach to go and program. But that's all that programming portion. Like I said, most of you are going to have to get a job at a controls company, or those of you who are managing are going to have to be leading technicians to this point. Which brings us to the technician. All right, so how do you do that? Well, this is where things start at that starting point, where you have to do an honest assessment of yourself. Do you have the electrical baseline knowledge? Do you understand electrical theory, Ohm's law, etc.? Do you understand baseline HVAC? Do you understand baseline building automation? Are you good at working with your hands, etc.? Let me take a sip of water real quick. Excuse me. I don't know why it's humid as heck here, so it should not be dry to me. Anyways, but you got that technician role. And so now you got to systemize your approach into that. So I've showed you a system for building automation programmer. Now for the technician, systemizing that, you're going to go and you're going to say, all right, how do I get into that role? Well, we'll go in here. We're going to type in building automation technician, and we'll see what it gives us. Let's see what job descriptions it gives us. Okay. So building automation technician must be physically able. Okay, I'm going to skip over that. Baseline understanding of mechanical knowledge and electrical knowledge to ensure proper implementation of I/O, testing of I/O, which that's inputs and outputs, and adjustment of field documentation. Okay, so what that basically means is this person has to understand how to go run electrical wire up inputs and outputs, test those inputs and outputs, and then update documentation. That's like a basic technician role, right? So how do you learn that? Well, this is where you would start to realize what is building automation. You'd start to study that. So understanding building automation, understanding the electrical, and understanding the HVAC. So from a building automation perspective, understanding something like building automation controllers, they take data from inputs, they process that data, and then they drive outputs, right? Take data from inputs, process it, drive outputs. Your job as a technician is to bring in the inputs and outputs to the controller so it can do its job. And real simply, you have to understand what inputs and outputs are. Fortunately for you, there's only so many input and output types. Right on the input side, we have resistive, dry contact, pulse, milliamp, and voltage. Right? Those are our standard input types. On the output side, right, we have internally sourced, externally sourced voltage. We have our voltage DC, and we have our milliamp outputs. And we have our floating outputs, which are a combination of 24-volt sourced voltage. Once you understand that, though, you basically know all of the major I/O types. And whether you work for Delta, Johnson, Siemens, Schneider, whoever, those inputs and output types don't really change. Sure, some controllers source their own voltage for powered sensors on inputs. Sure, some controllers will bridge or use triacs for externally sourcing voltage. But by and large, inputs and outputs are the same. So you've started at that individual system. Now you branch out. Electrically, what do you need to do? How do you run wire? How do you strip wire? How do you connect wire? How do you wire up different input and output types? Fortunately for that, once again, there's only so many ways you wire up inputs and outputs. A floating actuator, there's only really one way you wire that up. For proportional actuators, you have a couple ways to wire them up, but there's only a couple. So once you start to figure that out, then you have to say, okay, on the HVAC side, how and where do I install these and what sensors do I use? And how do I test that they're working? And then once you've got that, you've built basically the systemized chart of a technician role. And then finally, how do you interpret documents and update them? These are all things that if you get very clear on through YouTube resources, through stuff like our blog or our courses, or working a day-to-day job, you can clearly figure out how to do each one of those. Once you've built out those, that should give you, and you've worked in that role, then you can progress to that programmer approach that I've talked about as well. All right. I hope this systemized approach is making sense. It's not a hard and fast. We've done so many episodes on, what do you need to know to have a career in building automation, et cetera. But I wanted to give you kind of the logic thought process that if I were in your shoes, I would be going and using on a day-to-day basis to shortcut my career. If I knew I wanted to be a programmer, I would understand, what does a programmer need to know? What role comes before a programmer that supports that? And I would be doing this in the shortest amount of time possible, because the quicker you can get to that programmer role, the quicker you can gain the experience of programming. I'm not a believer of doing years and years in a previous role so that you can kind of have the experience. I believe the way that you actually have the experience is by having the experience in that role. I know that's kind of counter to our industry. Our industry, for some odd reason, seems to take pride in doing your time and doing years. And every time I bring it up on social or something, someone inevitably posts like a 10-page list of what a technician needs to know. And I look at that and I'm like, that's totally overkill. So just be honest with yourself. And I believe that if you follow the system, you should be able to progress rather rapidly through your career. And this can apply to anything: sales, project management, running a business, O&M work, contractor direct work, etc. Okay. I'm going to see if anyone has any questions. I'm just going to refresh this over here, see what's going on. And yeah, we'll be getting back on the technical topics. If you haven't joined our private community, I greatly encourage you to do that, because today, for example, we did a actual, I think it was 35-minute session on PID loops in this community. And the community is absolutely free. There will be a link at podcast.smartbuildingsacademy.com/353. And we'll be regularly doing educational sessions like that. So you'll be missing out if you're not part of that community. So you'll see the link to that when we post podcast.smartbuildingsacademy.com/353 in about an hour. Okay. Let me see. We got one question on YouTube. I believe I answered that right off the bat about how to get material. So you should be good there. And it is I'm going to totally butcher spelling. Temporary controls. Yeah, this is not how you spell contemporary. There we go. So if you go there, should be solid. Okay, what else we got? Any other questions coming in from anyone? Nope. Okay, well then, as always, thanks so much for everyone. I do want to let you all know there's about a week left in our workforce development program. So I'm super excited because we had one company sign up 6 people. One of them had to leave for personal reasons, but the other 5 are still there. They're profitable. They're executing work, and they were like post office workers and steel workers 11 weeks before the 11-week program. So there's still some slots open for that, but they close in a week. So if you're listening to this a week from now, those slots are closed. But I'll link to that at podcast.smartbuildingsacademy.com/353. Thanks so much. Let us know what you thought, and I look forward to seeing you in the next episode. Take care.